There we go. All right. So I find it really interesting to talk about these two studies back to back, so Clive Wearing and HM, because they both end up showing us the importance of our hippocampus in forming those long-term memories. And they're both really focusing in on the fact that our sort of procedural memories are different from our declarative memories. And so they didn't quite show this exact image in the video, but you can see that HM was missing the hippocampus and some of the other structures. So specifically the hippocampus, the amygdala, and other pieces in that area. And so that's very helpful for us because it was something that was done to try and help his seizures, and it did. But then we also were able to sort of hop on and study some of the after effects, which is why we do case studies and why case studies are so important in psychology. And so this tells us that those medial temporal structures, the hippocampus and the areas around it, are not required for a functional immediate memory, kind of like what we had seen when we were in looking at Clive Wearing. We're seeing that our immediate memory and our long-term memory are two separate systems. So we have functional immediate memory and non-functional long-term memory. And then we have the fact that the medial temporal structures, so the hippocampus and surroundings, are important for the formation of our semantic and episodic long-term memories. So lots of overlap there with Clive Wearing. And this is all, as I said before, very consistent in that three-component model that we've been looking at, where we have our sensory memory, and that sends information into our immediate memory. And then we can have information transferred into long-term memory for storage and brought back if we need to use it. And that system works with these. This kind of makes sense where we've just sort of damaged the last part of that setup, though we've added in this idea that long-term isn't sort of one idea. There's long-term declarative and there's long-term procedural memories in slightly different areas, but that doesn't completely break our system. It doesn't break our model. Our next case study actually does break the model, though. And this is the case study for an individual known as KF. And in this case, we don't actually know what the initials stand for. I've looked and looked, but it's just K and F. So this individual was in a motorcycle accident, and they had damage to their left parietal occipital region. So you can see the little red dot on the brain there. So they had damage to that part of their brain. And you might recall that the parietal region, especially on the right side, is very important in things like language and mathematics. So doing calculations, and that's where our language centers are stored. So we were expecting damage to things like language and sort of mental mathematical abilities. But what we ended up actually seeing, the more important thing, was that KF ended up having severe damage to their short-term memory. And I guess specifically their immediate memory, because it was short-term and working memory. And what we saw was that their ability to hold information was severely depleted. So we've talked about a normal digit span being 7 plus or minus 2. And that's what most of us would have. KF had a digit span of only 2. They could remember 2 pieces of information. And if there was a lot going on at that time, they might only be able to remember one thing at a time. So performing something like mental mathematics was effectively impossible because they couldn't hold enough information to actually do the process. And then the weird part here is that despite the fact that their immediate memory was not working, their long-term memory was completely intact. Not only could they recall things that had happened in the past, they could form new memories that they could then recall in the future. So in our 3-term model, or our 3-component model, the middle stage was missing, but the final stage was still functional. And so this situation with KF actually led to a bunch of spin-off models. And though we still use the 3-component model, and that's what we stick with for this class, because it does explain almost everything, this is a very good reminder that it's not always going to explain absolutely everything. So it's probably a lot more complex than our model would lead us to believe, which is probably in line with what we're starting to see with these weird things where people still have language functions, they still remember some things but not others. It's just a little bit of weirdness. But our take home from KF is that our long-term memory doesn't actually require functioning immediate memory. So step 2 can be non-functional, and we can still have step 3. So this goes against our 3-component model. This has led to a bunch of, as I said, spin-offs where they think that maybe what happens is our sensory information gets sent in 2 pathways, one to the immediate memory and one to the long-term memory, and that might be how we get around it. But there's a lot less consensus on that alternative. So we don't actually have a solid model that explains what's going on here. But I always find it interesting to point this out because a lot of the textbooks will tell us, A to B to C, and that's the pathway, and that's what happens. But in reality, there's a lot of sort of extra stuff going on that we need to keep in mind. All right, so those are our case studies, things that either support or end up sort of interfering with our ongoing model. But next I want to take a little bit of time and talk about some effective encoding strategies. So if we've been focusing on this moving of information from our immediate memory into long-term memory, what are ways that we can actually help that? And this is the section of the course that I really wish that we had the baseline to talk about earlier on. I feel like it'd be a lot better to talk about potential study benefits at the beginning of the class, but we rely on a lot of different bits of information, different brain areas, different concepts that we've had to learn as we got here. So at least I can hope that maybe this is helpful in the future. But when we're looking at sort of being effective in our encoding strategies, making sure that we're going to remember information better, we're going to be focusing on, again, a lot of more is usually better, different systems is usually better, and spread out over longer times is usually better. That's our general rule of thumb. And we can talk about some specifics here. So the idea of having spaced practice versus massed practice. Spaced practice is just the idea of spreading out your study periods. So instead of studying for 60 minutes straight, maybe study for 20 minutes 3 days a week. So by spreading it out, that actually helps you encode the information better so that it's easier to retrieve in the future. Massed practice is that all at once setup. So you do a lot better to spread out your study periods than to cram before an exam. Having been a student, I know that cramming is typically a very commonly used practice. Sometimes it's the only way that you can learn stuff, but especially if it's a topic that you're going to need in the future. So maybe you're studying for a topic that's going to come up again on the exam. You might want to study for your midterm using this spaced practice so that you don't have to study it again as extensively for the final exam. Or maybe you want to go on and take psychology in the future. So you could use this spaced practice to make sure that that information sticks with you a lot more intensively. So for myself as a student, I was a big fan of massed studying. I would study right before the test and then immediately forget it. But as an instructor, that doesn't really serve me very well. So what I end up doing is I go over my information lots of times, and usually I do it spread out. So I make the slides, and then I get a little bit of time, and then I present the slides, and then I get a little bit of time, and then I answer questions about the slides. So I get to go back to this information quite a few times, and over quite a few years at this point, and that helps the information stick with me. So I know this topic a lot better now as the instructor than I ever could have as a student, just because of the way that I'm exposed to the information. Oh, yeah. The final exam, I'm not 100% on the date. It is cumulative, but it's mostly based on the new information. So about 70% of the questions are going to be this chapter 7 and then the next chapter. I think it is just chapter 8. But that's going to be like 70% of the questions, and then the other 30% will come from the earlier topics. I don't, off the top of my head, remember the date. I'm trying to remember, because I know I teach at the U of A as well, and they haven't set their dates either because of the weird getting pushed online and then brought back in person thing has kind of messed with their schedule. But I would double check with the registrar because that's where I get the dates from. But as soon as I know for sure, I'll try and remember to send out an announcement. Ooh, yep. Perfect. Okay, that sounds familiar now that I've heard. So the 6th. Okay, and which site told you that? So I can look it up. Oh, okay. Okay, it's on the timetable now. Yeah. Okay. See, I will have to check that because the last time I had looked at mine, it said TBD, which had kind of confused me. So, ooh, ooh, yeah. Okay, interesting. All right. Well, I will double check that myself as well because, yeah, this is my first time doing in-person exams here, so it'll be interesting to see what happens. I know the setup for it. I just have to figure out the daytime. All right, so I will make a note to go look at that again. Okay, and then the last line here, we are sort of making this distinction that we think of studying in terms of things like episodic and semantic memory. So thinking about things that you've experienced, maybe you're telling a story or recalling an event, or maybe you're studying for a test and you have to remember a bunch of facts. That kind of makes sense that this setup would work in that case. But it also works for procedural memory. So if you wanted to practice riding a bike or throwing a baseball, you're a lot better to do numerous short exposures spread out over time than you are to do sort of one really long exposure all at once. And that actually makes sense as well. All right. So another thing that we want to kind of keep in the back of our mind, sort of tips and tricks to help us remember things. Another thing is the effective use of mnemonics. And so mnemonics are basically a kind of like a mental trick, a mental shortcut. It provides us a framework for encoding and recall. And so there's a bunch of different methods that we can use. I have sort of 2 slides full of them here. So keyword method, method of loci, acronyms, and initializations. I also include this list, which is a little bit more extensive, but I actually go into these examples in a little more detail. And some of these are actually similar concepts to what we've talked about already. So we talked about chunking as a method of expanding our immediate memory, so allowing us to hold more information at a single time. It can actually help us remember that information over the long term as well. The same as sort of elaborative rehearsal can help us pull on other systems and kind of let us hold information longer. That can be helpful in long term as well. So we get a little bit of bleed over between our immediate memory discussions and then our long term encoding discussions. But we're going to talk about each of these. So we already did chunking, which is sort of combining items into larger units that have meaning. So if you had a list of words and maybe there's 10 words on that list, but 3 of them are colors and 3 of them are animals and 4 of them are items, that might be a little bit easier for you to remember how many of each type you need to know. And then another idea for these simple mnemonics are just organizing things into hierarchies. So if you can create associations that have some kind of meaning to them, it can help you remember things. So if you had to remember a sort of something at the level of a house, and then the level of an entire neighborhood, and then the level of a city inside a country, if you can sort of stack them together like that under some kind of meaning, it'll help you remember all of those items, the house and the neighborhood and the city and the country. Whereas if you were trying to remember them separately, it might be harder to kind of keep them all separate. And so this is another one of those, as we make more associations, as we activate other systems and assign meaning, we help improve our memory. And this just helps show that it's not the act of like putting things into a hierarchy on its own. It's putting them into a meaningful hierarchy. So it only works if we're using existing systems of this thing is smaller and then bigger and bigger and bigger, or some kind of logical setup. You could do it in sort of order of importance or size or whatever. But if you have meaning, you end up having much better recall. For our visual-based mnemonics, these are the idea of sort of imagining what's happening. And so if we were doing our grocery list that we've used as an example throughout this chapter, maybe you remember the image of a loaf of bread and a jug of milk and a carton of eggs. And you can also start adding things. So here they break it down into non-interacting and non-bizarre. So you'd remember all three of your items just as is. If we were having non-interacting and bizarre, that's when you start adding weirdness or distinctiveness to the items that are happening. So a loaf of bread sitting on the counter is fine and dandy, but maybe it's a cartwheeling loaf of bread. The more weird stuff you sort of introduce, the more salient that item becomes, and the more it tends to stick in your mind. You can also have interacting, non-bizarre. So maybe you think of the loaf of bread and the gallon of milk sitting on the counter together. Or maybe you're using the eggs and the milk to make a cake, which was our intention for those two. So when they interact, it makes it easier because we're adding associations. And then you can have them interacting and bizarre to just sort of get the most on both levels of that. But this is really just leaning into that idea of the more salient you make something, the more systems you get involved, the easier it becomes to start remembering it. For some of our semantic mnemonics, these are when you use sort of like acronyms or the first letter of each word in order to make it more memorable. So maybe you had to remember the order of the colors of the rainbow. And so you were taught the mnemonic of Roy G. Biv to remember those. And so you have red and orange and yellow and green and blue and indigo and violet. And so those first letters help you remember the words that go with them. And it's almost like a shortcut that makes it easier for you to remember not only what they are, but what order they occur in. You can also use something like a narrative technique where you tell a story involving all of the items that you need. I've kind of done that with my sort of eggs and milk to make cake and then toast for breakfast the next morning. I've put them into some kind of order and again, just added extra steps to it. And those are all fairly simple and fairly logical, and they fit in with our, more systems is better, more time is better, all of that. But then we also have a method of loci. And this one was actually very difficult to try and explain to students until fairly recently when they did the BBC's Sherlock Holmes. And he does a fantastic job of explaining what a mental palace is, or a mind palace. And so this is a great example of a method of loci where you link what you need to remember with a place that you know very well. In a lot of cases, you would remember something like your own house. But in the Sherlock Holmes thing, he talks about his own mind palace, where he imagines sort of things that are stored in different rooms. And so you can actually use this sort of extra space to help you remember things, and especially things that are associated with one another. I use my example of a grocery list for this and thinking of my own house because what I would do is I'd walk through my kitchen. I'd stop at the fridge and I'd think, okay, what things are missing from my fridge? I can list all the things that would go in there. So eggs and milk would go in my fridge. And then I'd look at the counter next to the fridge, and that's where I leave my bread and my fruits and veggies that don't need to be refrigerated. So I'd sort of mentally stop there and think about what am I missing that would go there? What about in the cupboard? What about, do I need anything in the bathroom? So you can mentally walk through that space and think about what belongs in each of those places, and that helps you, again, just sort of introduce extra systems to try and remember things. I find this one really difficult. Sometimes it works with the grocery thing because it's like, okay, what's in my fridge and what isn't? But also I find introducing too many things just makes me more likely to forget everything. But some of these methods work better for others. And they tend to work in different situations. So you can imagine it's hard to put things into a hierarchy if they're not related. But if you can have a hierarchy, it helps. So all of these kind of get back to that same idea. And then the last thing is a little bit interesting, and this is the idea of retrieval practice. And this is going to be how we bridge our gap between encoding and storing things into long-term memory, and then how we retrieve things from long-term memory, which is going to be the topic on Friday. But retrieval practice is the idea of actually trying to retrieve information after you've encoded it. And the act of retrieving it actually makes you encode it better in the future. So this is the idea of maybe you're studying for a test, and instead of just looking over your notes, you're going to test yourself. Maybe you have cue cards, and you're going to ask yourself a question and check the answer on the back. And each time you do that, you can kind of envision it as reaching into your long-term memory, finding that information, and checking it against your cue card. And so each time that you do that, you're walking the same path to that piece of information and back again. And each time you walk that pathway, you sort of make it more solid, make it more tangible. And it actually makes it easier to recall that information in the future. And so this diagram here actually shows us some really good visual representations of this. So along the bottom, we have our retention intervals. So this is, students were tested after 5 minutes, after 2 days, and after 1 week. And then our y-axis is just the proportion of ideas recalled. So this is, again, that how many did they get correct? And so in sort of that tealy blue color, we have students just reread their notes. All they did was look over their notes. In the yellow, they would reread, but also test themselves. So maybe they'd use cue cards to test those concepts. And so we can see that after 5 minutes of just rereading and or retesting, they're about the same. There's not really a big difference between those two bars. Again, my pet peeve of not having error bars on intro psych texts makes it hard, but those are probably pretty much the same number. And then when we go into our 2 days, and even more clearly in our 1 week later, we see that the yellow bar is a lot higher than the bluish green bar. And that tells us that they recalled a lot more items if they were given the chance to test themselves as opposed to just reread the content. So by adding that extra step, by going and doing that retrieval process, they could actually have an improvement in their performance. So that's possibly something useful to help you in your study pursuits. I know that I made use of a lot of cue cards when I was an undergrad, and especially for classes that involve memorization, that is definitely a good course of action. All right, and then I think we're going to save retrieval for Friday. On Friday, we'll go over retrieval, and then we'll also talk about what happens when retrieval fails. And that should give us a good spot to wrap up for this chapter. So I will see you guys on Friday, and we'll go from there.